Okay, so today was a little bit of a strange day. The internet was not working for me at all. Just awful. Kids couldn't see what I was writing on the board. My audio was awful and it was lagging and it's terrible. So anyway, today I'm just recording the video for a review of piecewise functions and also a review of the material that we had up until now, and then adding in the new material, which is piecewise functions. All right. So just a quick side note, this is a life moment. Today after school at 3:30, today is Tuesday, September 22nd, there's going to be a big announcement from Tesla that has to do with the batteries that charge their cars. But if you just don't think outside the box here, you might just think, oh, so what? So some car battery has gotten a little bit better. I think that they have a battery that might actually change how we live, like within the next few years, because things can run off of batteries once they do this that have never done that before. Like they could have planes that run off of these batteries. Like your plane could be silent flying through the air instead of making all that noise. For example, your home could run off of batteries that charge overnight. And anyway, it's a big announcement coming. They're calling it Battery Day, 3:30 today. So check that out because I think it's really cool tech, and there's a lot of math involved in this. Not going to go into that right now, though. So let's get to the review. So to begin with, let me explain everything in this program called Explain Everything. If you had a function like f of x is equal to 1 over x plus 6, I hope you by now know that this denominator here can't have a 0 in it. So it's not that x can't be 0, it's that x can't be negative 6. So what you do is you take your denominator and you go, okay, whatever's on the denominator, x plus 6, has to stay greater than or equal to 0. And then you solve that. Nope, sorry, not equal to 0. And then you solve that. Okay? Because I want my denominator to be anything except 0. So then I subtract 6 from both sides. I have x is not equal to negative 6. All right? That's how you find a domain of a simple function with a denominator. Here's one where there's a numerator. So let's say that we have f of x is equal to square root of x minus 4. So what the domain is what you can safely feed the function. All right, and in this case, that part has to stay positive or 0. So that's what we do, is we bring it down and we say x minus 4 needs to stay greater than or equal to 0. Add 4 to both sides, and you have x is greater than or equal to 4. All right, so that's my domain. These are called implied domain problems. That's my domain of the red function. Domain is what you can safely feed the function. I can safely feed it things that are 4 or bigger than 4. Remember that 0 in a square root is not a problem. So when I put in this 4, it's totally okay. That's why it's or equal to 4, because 0 isn't a problem. 0 is a problem if it's in the denominator, like in my first example there. All right, so what if you have both kinds? So what if you had a function that was a square root of x minus 4, and on the bottom it was an x minus 8. Well, then you can think it through and go, okay, I want to make sure that this function doesn't crash. So I want the top part to stay greater than or equal to 0, and I want the bottom part to not be 0. So that's what you do. You pull this out and you say x minus 4. Notice I'm not using the square root, just what's under the root. X minus 4 has to stay greater than or equal to 0. And then on this part, I'm going to pull this out and say, and x minus 8 may not equal 0. So x is not equal to 8. And over here in yellow, x is greater than or equal to 4. If you put them all together on one number line, I'm going to do that in red here. That's the best way. Trust me on this. I've done a lot of these. To combine two different domains, a number line is way easier than trying to do it all with brackets and parentheses with, like piecewise. Sorry, that's coming in a minute. You're going to want to use a number line for this. All right, so here's -4. Greater than or equal to -4 means I would shade to the right. But wait, I'm also going to look at this 8 here, and it cannot be 8. Empty spot there. Do you get if I would have just shaded to the right, I would have thought it could be 8? All right, so there is the domain, what you can safely feed this function right here. You can safely feed it anything between -4 and 8, but not 8. Why not 8? Because if I put in an 8, see, it might work on the top, but it doesn't work on the bottom. It makes the bottom end up being 0 down here. All right, so there's my domain. Now, why don't you try to write that in 2 different notations. Try to write that in this kind where you have like unions, and then also in set builder notation. So try this. It'll make it stick better if you just pause the video right now and try to write that in interval notation and set notation. Even if you struggle with it, then resume the video. You'll be better off. All right, so try it. All right, I'm assuming you've paused the video. Now come back. You should have said that it was from -4 to 8, but there's a bracket on the -4 because it can be equal to -4. From 8 to infinity, and those have parentheses, okay? And then for this set builder notation, you could say x where, and then we could use these 2 things we had before, which were right here and right here. And I'd have x is greater than or equal to 4, and x is not equal to 8. Now, do we want to do a union of those or an intersection of those? We want to do an intersection of those. Or could we use a union? Actually, I think a union would work too. Now, that's weird, but I think it's true. I think a union is actually the better answer. Let me think. Nope. Oh, this is a tough one. You'd want an intersection because by saying this, I'm saying every answer except 8. Do you get the number line on this? Would be like a number line that doesn't have 8, but everything else is shaded. That means if I say union, I have to accept every number other than 8. So I wanted to be an intersection with this other one here, which was, here's where 4 is, and it was like this. It had to be an intersection of those 2. All right, so that was a tough one. That's why we reserve this for only if you're forced to do it on the test. You usually want to give your answers as number lines like this because it's easiest. Second easiest is this format, which is called interval notation. All right, so let's do one more where you see a problem with an implied domain and you write it and you use the right format, okay? So if I say f of x or y, it pretty much means the same thing. And I have, let's say, square root of x minus 6, and then let's go with x minus 10 down here. And let's see if you can do the domain for this problem and write it with a correct notation. All right, so hit pause, give that a try. I'm assuming you have already tried it, and here we go. You should say that this part, x minus 6, has to be greater than or equal to 0, and then that's x is greater than or equal to 6. And then this part, which is x minus 10, has to be not equal to 0, x not equal to negative 10. Okay, so now I draw my number line, and I say, here is negative 10. No, wait, it's positive 10. I know some of you were probably itching to tell me that, but you couldn't. Positive 10, positive 10. That's positive 10 right here, sorry. So we have positive 10 x is not equal to positive 10, which is right here, and x is greater than or equal to 6, which is right here. And be careful that I don't shade over the 10. Just because the one part says it can be 10 doesn't mean that it just automatically makes it all okay. 10 would not work. I can prove it by just putting in a 10 and showing you, yeah, the top part's fine, but the bottom part would be a 0, so we can't have 10. All right, that's one of the approved functions or ways to write it. I would write it this way on, if I was asked to give my answer in interval notation, I'd say from 6 to 10 with parentheses on the 10, union 10 to infinity. Okay, so that's another way that you could write that with a different notation. All right, so next one, we need to move into actually doing piecewise functions. So that's like this Franken function here. I'm going to pause while I write in a function and we'll solve that one. Okay, so here's what a typical question looks like. And I wanted to show you one that would be like a typical test question, but I think it would be easier to break this down and kind of understand this one if I show you an easier one to like give you context. Okay, so this is our function that we will graph in a second here, but before we do that, let's get an easier one. So here's a typical question that's like on the easy end of the scale. Do you get that this is a parabola, except I stopped it? It was, if I had continued it, it would have been like going like this, but I stopped it. Why? Because on the left piece of this function, the piecewise functions, right? The left piece, this function is a parabola. But on the right side of this function, let's say that this is the graph. All right, so that would be this function. F of x is, it's got two parts. It's a parabola, x squared, if x is less than or equal to 0. That was the green part. Or it's x plus 1 if x is greater than 0. So if I write them separately, it might actually help you to understand this. That's a function. Y equals x squared. F of x is the same as y, right? But it's only that if x is less than or equal to 0. If I write the whole other function out, it's y equals x plus 1. That's a parabola with a slope, that's a straight line with a slope of 1 and a y-intercept of 1. But it's only that if it's bigger than 0. Okay, so we usually put them together in one statement like this. That's how you're going to see your piecewise functions defined. But you could break them into two separate statements. All right. Now, I like to put a little dividing line right down where the two kind of share that same like border, you might say. I like to put a little dotted line down there. It's kind of dangerous because then you might think that's an asymptote. It's not an asymptote. But it helps me remember that this thing needs to pass the vertical line test or it wouldn't be a function. So do you see how as it went through here, it did not hit at 0, and down here it did hit at 0? If they had both been filled in circles, this wouldn't have passed the vertical line test. All right, so that's your basic one. All right, I honestly feel like I should do one more basic one. Instead of drawing the function first, I think I should just show you what another basic one would look like. F of x is equal to, let's say it's x plus 5 if x is less than 1, and it's x squared if x is greater than or equal to 0. All right, so where's my, not 0, sorry. I should make that 1. All right, so I'm looking at a piecewise function which has a left piece and a right piece. Left and right of what? I'm going to make a dotted line here where x would equal 1. And on the left side of it, I'm going to do this part, which again is y equals x plus 5. But only up until the dotted line. Now, if I'm like struggling with how to graph this, first of all, the y-intercept is 5, and so I go up here, put a dot there, and then it has a slope of 1, so it goes over 1 and up 1, but wait, over 1 and up 1. Let me see if that, I should probably be consistent on how I label my axes, so I should probably make this 1, 2, 3, 4, 5. Okay, and then if I'm going to graph y equals x plus 5, I'm going to start at 5 because that's the y-intercept. That'd be here. That's me starting with that. Okay, and then I rise 1 and I run 1, and right away I have to stop my graph. Why? Because I hit 1. And this has to be if it's less than 1. So I put an empty circle there. But I continue my graph back this way. Now, if you have trouble graphing, I suggest you bust out the old XY chart. If I'm trying to graph, hold on just a second here, y equals x plus 5, then I could make an XY chart for that. So if I put in a 1, I would get 1 plus 5 makes y would have to be 6. 1, 6 should be on my graph. But that, and it was right here. But I had to put an empty circle because it said that x had to stay less than 1. So it goes right up to it, but it has to be an empty spot there. Okay, another point that would go in here is if I put in x is 0, if I put in x is 0 into this equation, now I have y equals 0 plus 5, so that's 0 comma 5. And that was this point right here. Now how about if I put in negative 1 for x? Well, then it would be 4. I'm putting a negative 1 right here, and then it would be 4, okay? And that would be a spot like right about there. Okay, so that's just a reminder of how to do basic graphing. And now I'm going to graph this part. X squared if x is greater than or equal to 1. Why can't I just put in a parabola like a normal person, like this? Well, because it's not going to be allowed to be on the left side of the line. So I'm going to erase this right here and say, in fact, it can't exist until, it says right here, x is greater than or equal to 1. So there'll be a dot right there. And it's a filled in dot because it says or equal to right here. Okay, so there's a couple piecewise functions that are on the easier side. Now I hope you're getting the idea that they're something, like on the left side they're one function and on the right side they're a different function. So now let's go back to this one. Imagine this had been your test question. All right, so first of all, I'd figure out what the left and the right side are going to be. Okay, and this is about x is greater than or equal to 2. So then here's a dotted line I'm going to put in at 2. You actually don't want to leave that in your final answer because it looks like an asymptote, but it's a great way to show yourself, okay, the left side of the graph is this, the right side of the graph is that. Now, I have to admit, it's been a while since you guys have been taught how to read these things, but this is a square root function that's been shifted. Do you remember that the square root kind of looks like this? And it's been shifted right 1 because of that part inside the root. It's been shifted down 2, and it has been vertical reflection, also known as a flip. So when this is all done, it is going to be moved to the right and down, and it's going to be flipped, and it'll kind of look like that. The parent one looked like this, but it won't be that. It'll be flipped and moved, and it'll be looking like this one. This blue one right here. Okay. Now, I know for some of you that would have been just too much. Like, I can't remember all that stuff. But with this little coaching, maybe you'll be okay. Or you could always bring this function, rewrite it. Watch me. I'm doing y instead of f of x is negative square root of x minus 1 minus 2, and then I make an xy chart. But what do I know about my x's? They have to stay bigger than or equal to 2. So if I put in 2, it says it can be equal to 2, right? So I'm going to put in a 2 into that function, and I will have negative square root of 2 minus 1 minus 2. And that's going to be square root of 1, except it's negative because there's a negative on the outside. So negative 1 minus 2, which makes negative 3. So 2 comma negative 3. That would be one of my points that's super important. 2 comma negative 3 is right here, and it's a filled in dot because it said it was or equal to. All right, now let's try another point. What should I go with? Bigger x's? Yeah, it says x is greater than or equal to 2. So now I'm going to put in a bigger x, like 3. Okay, so if I put in a 3, I'm going to check for a second and see, will that give me a nice square root? Negative square root of 3 minus 1. Dang, that's the square root of 2. That's not going to work out real nice. So I probably don't want to choose that one. Maybe I should put in something bigger like a, I mean, this would work. You just have to get a weird decimal. What if I put in a 5? I want the smart kids to think about, why did I just put in a 5? Because now it's the square root of 4, which is 2. And then I make it negative because there's a negative in front, so it's negative 2. And then it's got a minus 2, which makes negative 2 minus 2 makes negative 4. So 5 would give me negative 4. 5 comma negative 4. It got messy. I'm going to clean it up. 5 comma negative 4. Okay, so this isn't just graphing. This is graphing with, this has been moved to the right, and it's been flipped. Double checking myself to make sure that I put that in properly. If I put in a 5, I get 5 minus 4 is 5 minus 1 is 4. Square root of 4 is 2. Negative 2 minus 2 is negative 4. 5, negative 4. It appears to be right. So my graph kind of looks like that. Now on the left side. On the left side, I have this part where x is less than 2. Well, can't I just graph this y equals, green's not going to be a good color here, y equals negative 2x plus 1? Yes, I can. If you remember that that's just a line that goes like this and it has a slope of negative 2, it's going to look like this. But it's got to stay in its lane. It can't go past 2. In fact, right when it gets to 2, it's going to have to hit an empty spot. So now I can either just draw it right up to it but not include it, or if I want, I could put an empty circle around this spot. That's kind of a really big empty circle, but it's trying to indicate I would be on that spot too except I'm supposed to say less than 2. Okay, so that was just the graph with a slope of -2 and a y-intercept of 1. All right. Now, honestly, on your test, most kids do fine on this problem. So if you're feeling intimidated, I just did one of the toughest ones we'd ask you to do. All right? And this, in a week from now, after you've had a chance to practice it a couple times, and the next time we get together, we'll review it again. This shouldn't be too tough. I mean, you're going to say, these aren't that bad. It's just graphing 2 graphs on 1 graph and being careful on the line in the middle. All right. So let's look at the next page. So I'm going to just do a real quick sketch of this one. It's x squared if x is less than or equal to 1. Well, here's where x is 1. Remember before I put in the little dividing line right there? Well, it's x squared up until that line. So x squared is just a parabola. It looks like this. But notice I have to stop right there. Can't keep going because it has to stay less than or equal to 1. Since it says or equal to, I own that line. And there we go. Next, in between 1 and 2, in this tiny little zone right here, that's the only place where this middle function can exist. And it's the line y equals 3. Y equals 3. I hope you remember what that looks like. Y equals 3 would just be a line that goes through like this. You know, a horizontal line at 3. So here's 1, 2, 3. And here is a horizontal line at 3. No, because you have to stay in your lane. You're not allowed to graph in the other zones. I'm only allowed to graph this between 1 and 2. So I'm going to erase this and keep my graph between 1 and 2. And then always be really careful at the borders. Good like advice in life too. X is, let's see, bigger than 1, so it can't be 1. It has to be an empty spot right there. And then it can be 2 because it says or equal to. So I'm going to fill it in right there. All right, last but not least, x is greater than 2, but it's what's the equation? Y equals x. If you forgot what y equals x looks like, we need you to know lots of little things. That's why my top 20 things are so important, or my basic 20 and the first 20, because these little things are kind of just expected that you would know that y equals x looks like that. All right, but why don't I just draw a line all the way across my graph? Because I have to stay to the right of 2. Okay, so it would have hit this spot right here at 2, 2. That's where 2, 2 is. Or I just put that little black circle. But I put an empty spot there. And now I know it has a slope of 1. It would have such famous points as 3, 3, 4, 4, 5, 5, 6, 6, etc. There's my piecewise function. It's been graphed. All right, I hope you're getting the idea of how a piecewise function works. So now, here's some practice on that. Now on this page, we have a word problem. Now, don't be all scared that it's a word problem. Notice it's x cubed for x is greater than 0. That's piecewise function. It's being defined. If you stay bigger than 0, the graph is x to the 3rd. Okay, so I think this won't be too bad if you make a little sketch of it. Remember, the answer key is posted if you get all confused. I'm not sure I would start with problem 65. All right, this next one, number 67. This to me looks like an upside down parabola, but it only works between 0 and 2. So right away I'd be picturing, okay, so here's 0 and here's 2. And my parabola only works in that zone. Oh, and it's an upside down parabola. Oh, and it has a y-intercept of 64. So let's say that that's 64. And it's an upside down parabola, so maybe it looks kind of like that. All right. So you'd have to actually graph it a little further to get your picture. And then you're supposed to think about why would t, which by the way is time, only be important between 0 and 2? Well, it's about an object being dropped off the roof. What do you think happens at time 2? All right. So if it's being dropped off of a roof, isn't its height going to be going down pretty rapidly? So I don't think it's going to be going up at the first. So I probably would need to change this and say, okay, it may start at 64 feet, but it's going to be going down pretty rapidly. And then at 2, it might hit the ground. Now, making some sense? You can look at the key to get the exact answer, but that's a start. All right, here on number 72, you have a more normal piecewise function. It's y equals 15n if it's between 1 and 25. It's y equals 13.5n if it's between 25 and 50. And it's y equals 12n if it's bigger than 50. All right. Now, I think you can skip this one right here. You may skip number 73. And that's it. So, I believe there may be even another problem that I can't see on my screen right now. You don't have to do anything about the lab. Just a reminder, we normally would be doing a lab right now. Be happy. We have decided to skip that for you and put it at some time in the future so you can focus on this new material of piecewise functions. There is some problems that were in yesterday's homework that you could do as part of this, and I think that would help you. You don't have to do them, but I think it'd be smart to go back and look at those. That'd be a great place to get some extra practice on piecewise. Next time we meet, we will practice piecewise some more, and you'll feel even better about it. And then that's the last melon. That one thing about piecewise, that'll probably just be one part of your test. The rest of it will be about domains and those different ways to write answers, with interval notation and set notation and that kind of stuff. The stuff leading up to today was more important than today. Today was only one question on your test about piecewise functions. So don't get all stressed about this. You'll get better at that. All right, so your homework is the same file that we're in, and you can see the answers already completed. Just do your part and get it done and turn it into the Dropbox by Friday. All right, that's all I have for you for the video for today.